Hey there, awesome armor science students. It's Mr. Corbett, and I just wanted to say hi to everybody. And some of you, I noticed, were having a bit of trouble understanding input and output force, direction, and magnitude. So I just wanted to go over a little bit of a lesson here with you guys, just quickly while we're talking about it. So let's just take an object, for example, my mug. And I still have coffee in the bottom of it. Some of you might have noticed the coffee in my mug last time when I did a video. But anyway, when I lift an object up, there's an output force and an input force. The input force is the force that I am putting in to lift it up. So what direction is that force that I am putting into the object? What direction is that going? So in this case, I have two directions. I have up or down. So I'm lifting it up. So what direction is the force that I'm putting into it? It is up, right? So the input force is up because I'm lifting it up. I'm not using a simple machine. I'm simply lifting it up. Now, the output force is what's happening as a result of me putting the force in, okay? So as I lift it up, what force is happening is acting on the object that I'm lifting up. What direction is the object going? It is also going up. So the input force direction is up, and the output force direction is also up, okay? When I'm not using a simple machine, the input force direction is equal to the output force direction. So it's both up. Okay. Now, you guys, one of your jobs was to create a simple machine. You were making a teeter-totter. Some of you made a teeter-totter. Some of you made pulleys. And I think there was another option, an inclined plane. I don't know if anyone made that one. And wheel and axle, I think was one of them as well. But in this case, I have a pulley, and I know a lot of the grade 4s made pulleys, and some of the grade 5s made pulleys. But this is a very simple pulley here, made with a bottle cap from a water bottle and cardboard circles that I cut out using cups, and then I put it on a barbecue skewer, and it spins nicely. Okay, so the difference with using a simple machine, many simple machines, they have an effect on the direction of the input. So the input is what I'm putting into it. So the side that I'm putting force into, well, that's the side that right now my hand is on. So I want to move the object up. So in this case, it's the basket is my object. So I want to move it up. So let's see what happens to my hand. What direction is my input force? So I'm putting in the force. So what direction is it going? The input force is going down. That's right. The input force is going down. Okay. So I'm going to pull down. And if I'm moving the object up, what is the direction of the output? So the input is down. What is the direction of the output? You tell me. Yes, it is up. Okay, so with a simple machine like a pulley, when the input is down, the output is up. Okay, so that's the difference. The input is what you put in, and the output is what happens as a result of the input. Okay, so I know some of you used a teeter-totter. That was one of the popular machines that you guys built, a teeter-totter or seesaw, or as we say in science, a lever. So I'm going to quickly rig up a lever here. This paddle, this little mini paddle, is my lever. Okay, so I'm going to push down on one end. This is my hand is on the input end because I'm putting in the power, it's input. What's happening to the other end? When I push down, what happens to the output end? It's going up. Exactly, that's right. So when you push down on the input, the output goes up. Okay? So I wanted to hopefully that'll help you understand the direction of force. If I have nothing here right now, I'm going to go back to and this is going to be magnitude of force. So let's say I have my little basket here, and I'm going to take this basket, and I'm going to put something into the basket. What's happening to the magnitude of force in the basket? If I put some mass in there, it increases or decreases, or stays the same? It increases because I increased the mass in the basket. It increases the magnitude of force. So if I increase the magnitude of force in the basket, what happens to my input force? Is it less that's required to lift it, more, or does it stay the same? It increases, right? Because I increased the amount of force required to lift it. In the basket, I increased the amount of force required to lift it. Now, the pulley does make it easier to lift. Some of you have discovered that. So that is also kind of an acceptable answer if you're comparing it to the amount that it would take to lift this normally. But anyway, guys, I hope that clears some things up for direction and magnitude of force. I'll see you later.